All right, in this video we're going to talk about the ellipse and the hyperbola. We'll look at the standard form for these and then talk about how you can graph it based off of that standard form, and it's really simple. So with the ellipse, you want to take the square root of the numbers underneath of the squared terms. So the number under x is 36. If we take the square root of it, we get 6. The number under the y is 16. If we take the square root of that, we get 4. All of the ellipses we'll look at will always be centered at the origin. So working from the origin, you're going to count 6 units along the x-axis, because 6 came from being under x, and mark a point, and do it in both directions, so to -6 as well. All right, now the 4 here, we're going to count on the y-axis 4 units down as well. And then you just connect those points with a nice oval shape, and we have an ellipse. All right, let's look at this one down here. Same exact thing. We'll have the square root of 4, which is 2, the square root of 49, which is 7. We'll count 2 on the x-axis, 1, 2, 1, 2, because that's under x. And then 7 along the y-axis, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. All right, mark your points, and you create your ellipse. All right, so that's just making the ellipse. Now, you'll also be asked for something that's called the foci, and there's a formula for that. The formula is, to get the foci, they call C is equal to the square root of a squared minus b squared. If you look at the notes for this section, it has all these formulas, right? I'm trying to explain this to you in a way where you can memorize it without the formulas, but I kind of need it for this. All this is the a squared and the b squared are the original numbers that you started off with in the problem in the denominators. And a is always has to be the biggest one. The a squared is going to be the 36. So the c value here is going to be the square root of 36 minus 16. So that's what? The square root of 20, which is 2 square root 5 if you reduce it. Okay, what you want to do with that, if you want to plot this, you can. You plot it along whatever axis, like whatever's the long part of the ellipse, you count on that. So in this one it'd be along the x-axis, 2 square root 5, which is going to be 4 point something, right? Because square root of 20 is between the square root of 16 and the square root of 5, so it's got to be 4 point something. I'm just going to estimate and put a point. And that is your foci. Okay? So, the foci. You can see the foci didn't really help us building the graph of the ellipse. We could do the same thing down here, but I'm going to skip that. I just wanted to mention it since it does ask for it in your homework. And jump over to the hyperbola. To graph the hyperbolas, we do kind of the same thing. The square root of 49 is 7, and the square root of 100 is 10. So you count just like before along the x-axis, you're going to go 7, 5, 6, 7 in both directions, and then along your y-axis, wow, we're going to have to go 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, mark all your points. Now, instead of drawing an ellipse or an oval shape, to create our hyperbola, you're going to make a box. So make all these points, turn them into, a rectangle that fits perfectly around those 4 points. It looks like that. Next, you draw in asymptotes that go through the diagonal of this rectangular box that you just made. Okay, and a hyperbola kind of of looks like two parabolas that either one opens up and one opens down, or they both, one opens left and one opens right. If we start off with X, you're gonna go on the X-axis to that point we made initially, and you're gonna create the one branch of the hyperbola over here, and then on the other X side over here, and that is what a hyperbola looks like. All right, let's go ahead and do it again down here. Notice down here, that we're starting off with a y term. So we're gonna have a hyperbola that opens up and down. But let's go ahead and create our box. So we have to take the square root of 36, which is 6, and the square root of 9 is 3. So since the 6 is underneath y, we count on the y-axis. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? Mark points. On the x-axis, we'll count 3. Create a rectangle. Right. Draw your asymptotes through the diagonal. And then, because we have our y squared term first, like I said earlier, we're gonna open up and down now. So, sorry, a little bit smashed in here, but we'll have our branches of our hyperbola looking like that. Now there's also foci that you're asked for these. And it's that formula, now it's c equals the square root of a squared plus b squared. So for this, your a squared and b squared are still those original numbers. So in this case, it would be the square root of 149. The foci will be inside of each branch. So if it opens left and right, you would plot this along the x-axis in both directions. What's the square root of 149 going to equal roughly? 12 point something, right? Square root of 144 is 12. So we would count out about 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Count out 12 this way. 1, 2, 3, 4, 5, 6, 7. Okay, and there's your foci if you needed to plot those. So that's basically it. Hopefully you can see why this is pretty easy, right?